Hey guys, it's Mrs. Stevenson. Today I want to talk about some geometry stuff, um, which in particular we'll look at hexagons and octagons, which come up all the time in math as school problems. Just geometry in general. We'll also look at like pyramids and cones. Also, I'm not going to cover spheres, but you should know the formulas for surface area and volume of a sphere. So in particular, let's start by talking about regular hexagons. Okay, so here is a diagram of a regular hexagon. Um, so I think you all know that a regular hexagon can be split up into 6 equilateral triangles. Okay, and you should all know the formula for the area of an equilateral triangle is side squared times the square root of 3 divided by 4. So for example, here's the side. And then, because these are all equilateral, and we know that because, a hexagon is divided into 6 triangles. You've got 360 degrees divided by 6. So each of these is 60 degrees. So you basically got, side, side, side. So we know the area of one of the triangles, so therefore the area of the hexagon is just 6 times that. So it's just 6 times side squared square root of 3 over 4. And then if we just simplify that, we can reduce here and here by taking out a factor of 2, and we get 3 side squared square root of 3 over 2. Okay, so is it important to memorize, this formula? Yeah, I don't know. It is super important that you know this formula, because if you know this formula, then you can easily get this one. All right? So, not as important to memorize this one, but you must know this one. Okay. Now, another way to find the area of any regular polygon. And so, yeah, we're just talking about regular polygons here, not irregular ones. Okay, so this new way, and I don't know that we really talked about this last year, upperclassmen, I don't know if you're familiar with this or not. Area equals A times P divided by 2. Okay, so this is a really good thing to know. So what are these things? Okay, so A is the apothem. Apothem. Okay, so it's kind of a funny word. It's kind of like, say, if you were going for a hike and something scurried across your path and you said, hey, look at that apothem. Pretty similar. So no, the apothem is the perpendicular distance from the center to the middle of a side, right there. Okay, that's the apothem. And P, of course, is just, I won't write it out, it takes me too long with the little pencil, but it's the perimeter. So go ahead and write that on your notes. P equals perimeter. So for any regular polygon, the area is the apothem times the perimeter divided by 2. Okay? So let's just take a closer look at one of the triangles. Okay, I'm going to erase this stuff. Let's do this. So let's look at, this one triangle here, down here. Okay. So again, the apothem is this perpendicular distance. Okay. So this is one equilateral triangle from a regular hexagon. So we know, each of these angles is 60 degrees. So therefore, let's just bring it back down here to the one triangle. So we know that this is 60 degrees. And, we know this is perpendicular, so it's 90. So therefore, this is 30 degrees. All right. And then we know that this is one of the special right triangles. Okay. I always remember, okay, across from 30 degrees is the small side. So that's 1. Okay. Across from the 60-degree angle is the bigger side. So that's square root of 3. And then, of course, the hypotenuse is 2. Okay. So this is just something you should have. You don't even have to think about it. When you see a hexagon, you can break it down into triangles, and then the triangles into the right triangles. So whatever the apothem is, then say you could figure out the other sides if you needed to. All right, I'm going to erase this stuff and scooch down again. Okay, regular octagons, and we see these sometimes, maybe not as often. There is a formula for the area. It's not a bad idea to know this. So the area of a regular octagon is 2 times the quantity, 1 plus the square root of 2, times the side squared. Okay, so where, of course, the side would be one of these distances. All right, so then let's look at what are the central angles here? Well, it's an octagon, so it's split into 8 parts. So each angle, it's 360 degrees total, and then divided by, there's 8 angles in the middle. Okay, so that is 45 degrees. So in other words, each of these angles is 45 degrees. So like if we were going to try to, draw the apothem and then make a triangle out of this, well, then we're splitting 45 in half. So that makes each of these, what's 45 divided by 2? 22.5 degrees. It's not going to be one of our special right triangles. So that doesn't really do us so much good. But there can be some other forms of problems which maybe involve, like, we could make this whole thing into a square if we did this. If we just added these corners back on, right? Kind of like this. Okay, so if we did that, then, let's like look at this corner that triangular corner that we just formed here. So we know that, this is a 90-degree angle here in the corner, and that these two angles have to be the same. So therefore, they both have to be 45 degrees. Okay? So both of these are 45-degree angles, and this is a special triangle. Okay? And we know for a 45, 45, 90 triangle that the ratio of the sides, these are going to be 1, 1, square root of 2. Okay? So that is something that can help with potentially octagon problems. Okay, I'm going to erase this and scooch on to the next page. All right, pyramids and cones. And actually, a cone is just a special case of a pyramid. All right, and I know that you guys know this. The volume of a pyramid or the volume of a cone is just 1/3 base times height. So no matter what shape the base is, it's just 1/3 base times height. So specifically, let's look at cones. All right, so here's a really great diagram of a cone. So you've got your radius, okay, so that of course is r. You've got your height, okay, that is h. And then you've got what's referred to as the slant height. And this I don't think we've talked about as much. It's this distance, okay, along the side of the cone. And this is usually referred to as L, lowercase l, okay? So, using the Pythagorean theorem, then the relationship between these is, of course, that h squared plus r squared equals the slant height, or lowercase l squared. Okay? So, particularly for a cone, again, just the generic formula for volume is 1/3 base height. But because the base here is circular, we know that the base is pi r squared. So we can write this as 1/3 pi r squared times height. Okay? Now the thing that maybe we haven't talked about so much in the past is the surface area of a cone. Okay? So the total surface area is this. So it's pi r times the quantity r plus the square root of h squared plus r squared. All right, so that looks alarming, but it's not so bad. So for one thing, the square root of h squared plus r squared, that is just equal to L, the slant height. Okay, that just comes straight from here. If you take the square root of both sides, you just get L equals the square root of h squared plus r squared. Okay? And now let's do this. If we multiply this out like this, all right? So I'm going to get the total surface area equals pi r squared plus pi r, and then let's just put in L. Okay? So the total surface area is composed of two parts. Pi r squared, that is just the base area. That's just the area of the circle on the bottom. We know that. Area of a circle, pi r squared. That's all that is. Pi rl is called the lateral area. Okay. So if you want the total area, and sorry, the lateral area, of course, is just all the rest of this, you know, surface of the cone going all the way around it. Okay. So if you want the total area, you have to add the circle on the bottom plus the lateral area. Or maybe you just want the lateral area. That's just pi rl. Okay? All right, so that should be everything you need to know. I'm going to erase this and scooch down. To solve your raffle problems for this week, you know, I think they're pretty straightforward. Definitely 1, 2, 3, 4, and 5 are fairly straightforward. 6 maybe a little more involved. 7, like I said, you need to do this on your calculator because you're going to have to take a tangent. And if you haven't studied basic right triangle trigonometry yet, that's okay. Just indicate that on your answer line here. If you want to run your answers by me in advance to make sure you got them right, that's fine. You can email me. You guys should know, or most of you should know, my email address is thepack. Oh man, I just totally messed that up. No, thepack at charter.net. So you can email me your answers. I'll check them in advance for you before you turn them in next Thursday to Mrs. Adler or Mrs. Bird. Or you can take a picture of your answer sheet and you can text it to me. My cell is 509-430-0198. So either way, if you have questions, if you want to check your answers, let me know. Thepack at charter.net or my cell phone. All right, I'll see you guys later.